sneak preview of what's going to happen after spring break. So remember, if I take something basic like the limit as x approaches infinity for a graph like y equals x, that if I plug in x equals 1, x equals 2, x equals 3, y is going to be equal to 1, 2, and 3 respectively. Let's go crazy. Let's go with 10 or 1,000 or 1,000,000 even. Well, then y is going to explode up as well. So as x gets closer and closer and closer to infinity, so does y. So the limit as x approaches infinity for y equals x is y goes to infinity as well. But on the contrary, if I have 1 over x, so in other words, I'm going to plug in numbers as x gets closer and closer to the biggest number humanly possible. So I've got 1 over 1 over 2 is 1/2. 1 over 3 is, I plug in x equals 3, I get 1/3. Plug in x equals 4, I get 1/4. X equals 10, 1/10. X equals 100, 1 over 100, and so on and so forth. If I plug in x equals 1,000,000, I get 1 over 1,000,000. So 1 divided by 1,000,000, that's a whole bunch of zeros getting closer and closer to 0. So I can conclude that it's not actually going to reach y equals 0 as x gets to infinity, but the intent as x approaches infinity, 1 over infinity is 0. Okay? So let's use these principles and let's do 3 problems in 2 ways. So for instance, this is a bit ridiculous. The limit as x approaches infinity for 5x squared minus 8x plus 9. So I'm showing you guys that if I get my thought bubble and I plug in infinity, oh, come on, green, there you go. There we go. So if I get my thought bubble out and I go 5 times infinity squared minus 8 times infinity plus 9 over 7 times infinity plus 3. Well, when I was in 12th grade and I saw this, I was like, you're just messing with me at this point, aren't you? But what I was taught was to look at the leading degree. So remember the degree on the top, right? What is the highest exponent for x? Well, the top is a degree 2 polynomial, a second degree polynomial. And the bottom is a first degree polynomial because if there's no exponent, it's automatically to the first power. So what we really should be looking at are the degrees of the polynomial. So let's just examine how ridiculous this is. So this is all thought bubble work. This is all stuff that's in my head. Well, infinity squared times 5, I don't care about minus 8 times infinity plus 9. I only care about the leading coefficients. 5 times infinity squared, let's just call it what it is, infinity. And 7 times infinity plus 3, yeah. 7 times infinity plus 3, yeah, that's infinity. Well, I don't really know what to make of this. So let me get my thought bubble. And I'm a little bit confused. But the idea is it all has to go somewhere as x gets closer and closer to infinity. So what I do for this problem is I can multiply by 1 over the smaller degree. So let me show you on problem number 1. So this is the limit as x approaches infinity for 5x squared minus 8x plus 9 over 7x plus 3. So what I'm going to do is look which one has the lower degree. The bottom. So the degree is 1. So what I'm going to do is multiply the top and bottom by 1 over x to the first power. And I'm going to distribute to all the terms on the top and all the terms on the bottom. So what this does now is this creates the limit as x approaches infinity. So now I've got 5x squared over x minus 8x over x plus 9 over x. And then I've got 7x over x plus 3 over x. So let's just do some algebra at this point. The x for negative 8x over x cancels out. The 7x cancels out over here. And I can cancel out x squared over x by canceling this out and making this x to the x to the first power. So now I've got the limit as x approaches infinity for 5x minus 8 plus 9 over x. All that over 7 plus 3 over x. Now I'm going to examine this case by case. Well, 5x, 5 times infinity, let me put thought bubble right here. 5 times infinity is equal to infinity. Negative 8 is negative 8. 9 over infinity is going to be equal to 0. 7 is equal to 7. 3 over infinity is equal to 0. So when we look at this, this becomes 5 times infinity on top over 7. Five times infinity divided by 7 is infinity. So that was confusing. Let's see if another practice problem will make sense. So I've got the limit as x approaches infinity of 7x plus 3 over 5x squared minus 8x plus 9. You get the idea that if I plug in infinity on top and infinity on the bottom, I'm going to get infinity over infinity. I'm not happy. So what can I do? Well, I look at the top. And this time the top is the exact same one on the, the problem is pretty much identical. I just flip the top and bottom. So now the degree on the top is 1, and the degree on the bottom is 2. So what I'm going to do is divide both the top and bottom by the smaller degree. So I'm going to rewrite the problem, the limit as x approaches infinity of 7x plus 3 over 5x squared minus 8x plus 9. And I'm going to multiply the top and bottom by 1 over the x degree of the smaller x degree. So I'm going to multiply the top and bottom by 1 over x to the first. Because now I get the limit as x approaches infinity for 7x over x plus 3 over x over 5x squared over x minus 8x over x plus 9 over x. All right, let's do some canceling out. Well, x over x cancels out, x over x cancels out, x squared cancels out with x, leaving me with x to the first. So now I'm left with the limit as x approaches infinity, and if I were to just plug it in, I'd get 7 plus 3 over x over 5x minus 8 plus 9 over x. And now, when I plug in infinity to this problem, I'm not plugging in the limit as x approaches, I'm plugging in infinity at this point. So now I've got 7 plus 3 over infinity over 5 infinity minus 8 plus 9 over infinity. So let's examine this with critical thinking. So the top is 7 plus 3 over infinity. Well, 3 over infinity is 1. 3 over infinity is 0. So in essence, I've got 7 plus 0, or 7. Then I've got 5 times infinity, which is infinity, minus 8. You don't stand a chance against infinity. Infinity minus 8 is practically infinity. And then I'm going to have added 9 over infinity, or 0. So basically 5 times infinity is infinity minus 8 plus 0. Or in the end, we get 7 over infinity. Well, let's just go back. If I have a number over infinity, that typically goes down to 0. So the limit as x approaches infinity of 7x plus 3 over 5x squared minus 8x plus 9, it converges to 0. Okay? Now, I'm going to throw a curveball. Now we look at the degree on the top and the degree on the bottom as x gets closer and closer to infinity. So now the degree on the top and the degree on the bottom are identical. So the top is a second degree polynomial and the bottom is a second degree polynomial. And now we're going to examine what is going on. So now I'm just going to multiply the top and bottom. Sorry, I'm going to rewrite the problem. The limit as x approaches infinity for 5x squared minus 8x plus 9 over 7x squared plus 3x. Well, I plug in x equals infinity, I get infinity over infinity. I have no idea what that means. But I do know that I can multiply the top and bottom by the smaller of the 2 degrees. So I'm going to multiply the top and bottom by 1 over x squared. So now, if I multiply the top and bottom by 1 over x squared, that makes this the limit as x approaches infinity. We've got 5x squared over x squared. We've got negative 8x over x squared. And we've got positive 9 over x squared over 7x squared over x squared plus 3x over x squared. So now let's do some algebra. Well, x squared over x squared cancels out. And 8x over x squared. So let me just rewrite this problem really quick. So that becomes 5 on the top and 7 on the bottom. Negative 8x over x squared. Well, that cancels out the x on the top, and that only leaves x to the first on the bottom. And that 3 becomes canceled out with the x on top, and that leaves me with x to the first on the bottom. So now I've got minus 8 over x plus 9 over x squared, and now I've got plus 3 over x. And now I'm going to plug in x equals infinity. Well, I take a look at negative 8 over x, where x is infinity. Negative 8 over infinity is so close to 0, it's practically 0. 9 over infinity squared. 9 over infinity squared. Yeah, that's 0 if I've ever heard one. It's so close to 0, it's practically 0. And then 3 over infinity, that's also 0. So in essence, we've got 5 minus 0 plus 0, or 5. And 7 plus 0 is 7. So if you look at this, as x gets closer and closer to infinity, the curve starts to flatten out and go to y equals 5/7. Isn't that awesome? Oh my goodness. So I know what you're thinking. Do we have to do this method? Well, when you go to college, your teacher is going to teach it this way. You look at the degree on the top, you look at the degree on the bottom, and you analyze. But you know what's coming. You know what cheat code I like. Oh yeah, it's back, and I love it. Again, when I took Calculus 1 and I was like, okay, all right, I like derivatives better than limits. I guess I could do limits. It took me 4 years to do this, and then I finally got an A in Calc 1. And then my Calc 2 professor was like, okay, I'm going to show you L'Hopital's rule, where basically if you have the limit as x approaches a for some function, in this case function over function, and you get an indeterminate form, 0 over 0 or infinity over infinity. Well, if and only if you have a 0 over 0 or an infinity over infinity from direct substitution, you can take the derivative of the top and the derivative of the bottom until that 0 over 0 or infinity over infinity goes away. We looked at each other like, come on, why did you give this to us last year? This is so much easier than examining the degree of the top and degree of the bottom and doing like infinity squared, infinity cubed, comparing infinity to the 7th power to infinity over the 8th. It's like, I get it now, but when I was 19, 20 years old, I was like, come on, man. Anyway, so let's do some thought bubble work, and let's do these 3 problems using L'Hopital's rule. So if I plug in x equals infinity to this, I get 5 times infinity squared minus 8 times infinity plus 9 over 7 times infinity plus 3. Well, let's just spoil it. That's infinity over infinity. I have no idea what that means because it's an indeterminate form. So what I'm going to do is I'm going to take L'Hopital, the limit as x approaches infinity. I'm going to take the derivative of the top. The derivative of 5x squared with respect to x is 10x. The derivative of negative 8x is negative 8. And the derivative of 9 is 0. So forget about it. The derivative of the bottom now. The derivative of 7x with respect to x is 7. And the derivative of 3 with respect to x is 0. So now I'm left with the limit as x approaches infinity for 10x minus 8 over 7. Now can I legally plug in infinity? Let's give it a shot. So I'm going to plug in 10 times x equals infinity. 10 times infinity. Yeah, I like my evil laugh when it comes to infinity. So 10 times infinity is infinity. Minus 8 doesn't even scratch the dent. It doesn't even scratch the surface of infinity. Infinity is so great. It's so awesome. But the idea is basically I get infinity divided by 7. Well, as x gets closer and closer to infinity, y gets closer to infinity over 7, which is infinity. So using L'Hopital's rule, I find this much easier. All right, let's do problem number 2. Once again, you can do thought bubble. I'm not going to waste your time. If you do thought bubble, you plug in 7 times infinity plus 3 over 5 times infinity squared minus 8 times infinity plus 9. Basically, you get infinity over infinity, and I don't know what that means. I have to compare an infinity to an infinity. Let's break this down. Let's make this easier. My buddy L'Hopital, my calculus 2 buddy, L'Hopital to the rescue. And I'm giving you the cheat code because I find this much easier. So let's take the derivative of the top. The derivative of the top is the derivative of 7x plus 3 is 7. The derivative of 5x squared is 10x. And the derivative of negative 8x is negative 8. And the derivative of 9 is 0. Now, is it legal for me to plug in x equals infinity? Thank you, L'Hopital's rule. So my good buddy L'Hopital is going to give me 7 over 10 times infinity minus 8. So I'm going to plug in x equals infinity. I've got 7 on the top. 10 times infinity is infinity. And infinity minus 8 is, it's infinity, man. It's so strong, you can't make a dent in it. 7 over infinity, well, as x gets closer and closer to infinity, this converges closer and closer to 0. So 7 over infinity is 0. Okay? All right? And now we're going to plug in infinity for x. You get the idea. And now I'm going to plug in infinity for this. So now I got to compare 5 infinity squared minus 8 times infinity plus 9 over 7 infinity squared plus 3 infinity. I'm just going to pay attention to the leading coefficients if that's okay with you. In other words, I get infinity over infinity, and I have no idea what that means because that's an indeterminate form. So now, instead of multiplying by 1 over x squared and trying to make sense of all this, my good friend, the greatest cheat code in the history of calculus, L'Hopital. Oh, L'Hopital. Take the derivative of the top for me. 10x minus 8 on the top over 7x squared plus 3x. That derivative is 14x plus 3. So I'm going to try direct substitution, but you notice that I'm going to get 10 times infinity minus 8 over 14 times infinity plus 3. In other words, 10 times infinity is infinity minus 8. So infinity minus 8 is still infinity. 14 times infinity is infinity. Infinity plus 3, yeah. Infinity plus 3 is still infinity. So the idea is I still have infinity over infinity, and I get to do L'Hopital's rule once again because that infinity over infinity has not left. So now I'm going to take the derivative of the top and the derivative of the bottom. 10x minus 8, the derivative of 10x is 10. And the derivative of 14x is 14. The derivatives of the constants cancel out. Now, it's just a constant. So the limit as x approaches infinity is 10/14. But I can simplify this fraction by dividing the top and bottom by 2. And I get the limit as x approaches infinity for this gigantic function, 5x squared minus 8x plus 9 over 7x squared plus 3x, is 5/7. So that's not a coincidence. And after spring break, we're going to examine some even further cheat codes. But for now, if you love L'Hopital's rule, use L'Hopital's rule for indeterminate forms. See you guys. Have a restful spring break. Oh, I guess I'll see you in 10 days? Wow, it's going to be that long? Anyway, have a great break. Stay safe. Wash your hands. Stay healthy.